parabola. Let's look at properties of a parabola.
Excuse me, teacher.
Yeah.
But yesterday we looked at an ellipse.
Yes.
Yesterday we looked at an ellipse.
Yes, I said Monday will be for an ellipse, Tuesday will be for a parabola. Eh? Do you remember? Then the other thing, I am also doing some short videos on my TikTok, and there's another YouTube channel I'm opening for the short videos called Simple Learning. You'll always check there for further definitions. I'm going to make sure they follow the order of what we have been covering. So if I don't finish up today the parabola, there will be some short videos that will follow. I'll always also share them on your WhatsApp so that you can easily follow. Okay? So don't worry about waiting up to January to resume class or to resume and finish. And then also be ready for a test. I'm going to bring a test on this, on whatever we have discussed mainly. We shall have a test on statistics and probability alone. We are going to also have a test on pure math, a little bit combined with some integrals. Yeah. So we should be ready for all that. So we shall discuss them after this week. We shall have to discuss them. Those are some of the discussion days we shall call for. That come, we pass through the numbers, we pass through them. Okay, one, its shape. This is the shape of the parabola. For those of us who don't know how it looks like, some of you might have joined today. You never know, someone might have missed all those weeks and he has showed up today. So you didn't know how the parabola looks like. This is how it looks like. Whereby this parabola is y squared is equal to 4a what? 4ax. Then the second item, its general equation is given by y squared is equal to 4, y squared is equal to ax, where a is a constant. It has a vertex at a point 0, 0, like that one. 4, the focus sorry, I think I got some network malfunction. Okay, let's review what we are trying to say. So we are saying properties of a parabola. And I showed you one, it was its shape, which was of the form like this one. And this is the parabola of y squared is equal to 4ax. This has the x-axis. This has the y-axis. Then I had said 2, the general equation of the parabola is y squared is equal to ax. Then 3, it has a vertex, for example, reference to that one at a point 0, 0. 4, it has a focus at a point S0. 5, the directrix is x is equal to negative a, or at x plus a is 0, the equation of the directrix. 6, the y-axis is a tangent at the vertex of the parabola. As you can see that image. 7. The x-axis is the axis of symmetry. Then also, 8, we can talk about what we call the lactus rectum. The lactus rectum is the length of the focal chord. Length of the perpendicular focal chord, i.e. the chord through the focus and perpendicular to the x-axis. This length of the length of the lactus rectum is obtained by putting x is equal to a in the equation y is equal to 4ax. So y squared would be 4a times a, which gives us y is equal to plus or minus 2a. Therefore, the lactus rectum is always 4a units. It's always 4a units. So how does it look like? Let me show you the shape of that. If I have this as my parabola, and I have this as my axis, then we expect the following. This is the parabola. And this is the focus. Remember, the focus is A0. Then the perpendicular that passes through the focus from the parabola up there to down here is what we call the lactus what? Rectum. So this lactus rectum is what we are seeing here. And this is at a point x is a, y is 2a. Even here, x is a, y is negative 2a. That's why we got y as plus or minus 2a. This is y-axis. This is the x what? Axis. So this length, which is red, is what we call the lactus rectum. And according to this, the height here is 2a up, even down is 2a. So this is 2a from the x-axis to where the point is. Even this is 2a from the x-axis to up there. So that's why we say the length of the lactus rectum is 4a. So the last point we can note is the parametric coordinates. Yesterday you saw the ellipse has parametric coordinates, which are a cos theta and b sin theta. Even the parabola has. The parametric coordinates of a parabola are x is equal to 80 squared and y is equal to 80, y is equal to 80. You've seen some of these in Backhouse 1, but you didn't know that it was a parabola by then, where t is a parameter. So these parameters are going to come when they are very handy, they are very sensitive, they are very needed in whatever is coming next for the parabola. So most of these other items of finding dielectrics focus, they are just in the introduction of parabola. Now we are going into details to see how the parabola can be treated or behave with other definitions. So with that, if this is a point, for example, this is how your parabola can look like. And this is a parabola of this kind. Then with this axis, this can be the parabola y squared is equal to 4ax. So that point, which is having parametric equations, can be in the form 80 squared to 80. That is the parameter T1. If I have another point down this way, it can have 82 squared to 82. So this could be point 2, this could be point what? Point P. So any point that lies on the parabola can have parametric equations of that order. Okay, so with that, we are ready for further definitions. And the first definition we are going to see here is the equation of the tangent to a parabola. So the first definition we are going to see today, which comes with a parabola, is the equation of the tangent to a parabola. And I want you to be very sensitive. These are very common questions. Tangents, what points of intersection with a line, and so on. Equations of the tangent to a parabola at x1, y1. So that is why some of these items come when you have finished some topics. You don't rush these topics in the beginning because there's some knowledge you always need to have some of these items taken into consideration. So if I have this as my axis, which is the y-axis, this is my x-axis, and I have this as my parabola. And just know, whenever we have a tangent, we also have a normal. So this is our parabola. And then this can be our line, which is tangential to the parabola. Okay? Then we expect the following. One, we shall expect to have a point here, which point of contact is x1, y1. This is our tangent. This is the parabola y squared is equal to 4a what? X. This is the apex 0, 0. It has its focus somewhere around here, a0. Now, given that y squared is equal to 4ax, we can differentiate and get 2y of dy dx is equal to 4a. And you realize that dy dx is actually 4a out of
Excuse me, teacher.
Yes, please.
My question is it is it automatic that the parabola must face the same direction?
Someone want to take that screenshot. Is it the same that? Is it a must that what?
The parabola must face the same direction as I see.
The parabola all the time? No. We are just using one basic reference point. This is just a basic parabola. But if you want to use the other items, you have the other shapes It will depend on the equation you are considering. So here we are considering y squared is equal to 4ax. So if you consider y squared is equal to 4ax, then by all means, the parabola should face like that. Okay?
Okay, sir, thank you.
Unless when you're starting another equation with a negative, with x squared is equal to 4ay. But as long as we are using this for just definitions, so that you understand how definitions can be realized. Therefore, dy, dx, which is the gradient of the curve at that point, which point where x is 1 and y is 1, shall have 4a out of y1. Now, which becomes the gradient? This is the gradient.
Teacher, where is that 2?
Yeah?
That 2.
Sorry, there's a 2 here. There's a 2 here. Okay, we can simplify it to what? To 2a over y1. Eh? Okay, and we call this the gradient of the tangent of the tangent at x1 and y what? And y1. So the tangent to the parabola. So if that is the gradient of the tangent to the parabola, remember how to find the equations of a line. You can say y minus y naught out of x minus x naught is equal to always the gradient. So in this case, our gradient is 2a out of y1. Okay, so we shall have y minus y1 out of x minus x1. This will give us 2a out of y1. With this case, you can make y the subject by simplifying. So you realize y1 minus y1 squared is equal to 2ax minus 2ax1. Okay, so this will give us 2ax minus y1 plus y1 squared minus 2ax1 is equal to 0. Becomes the equation of the tangent to a parabola at a point x1, y1. So when they give you a point x1, y1, and you know this equation, you substitute straight away. If you don't know, go back to basics. Differentiate the function of the curve, get the gradient of the tangent at that point using the basic knowledge of curve sketching, Backhouse 1, then you do like a traditional student and you get those solutions. Okay. Also, you should also recall that x1, y1, however much it's a point where the tangent is, it also lies on the parabola. It also lies on the what? On the parabola. So if it lies on the parabola, this is what is expected. 1, if it is lying on the parabola, y1 squared is 4ax1. So I can substitute for either y1 or for x1. Okay. Now, in that case, if this is equation 2, and this is my equation 1, do you see where we have y1? I can substitute and have 2ax1 minus y1 plus 4ax1 minus 2a x1 is equal to 0. One can also conclude that 2a x, okay, this was 2ax, not a subscript, minus y1 plus 2ax1 is 0, is also an equation for a tangent to the parabola. And one can say y1 is equal to 2a brackets x plus x1 is the equation of the parabola. This is also correct. I mean the tangent to the parabola. So all those are correct. So they can ask you to show the following. Even they can ask you to show, you show for me the second one. Show that You'll show it in your free time. Show that the equation of the normal to a parabola at a point x1, y1 is given by y1 x plus 2a y minus y1 x1 minus 2a y1 is equal to 0. So you will show this in your free time. Remember, the only condition for the normal is it has an inverse gradient, which is negative, as per that one of the tangent. Okay? So you can have that down. Take the screenshot. We take a look at examples on the first definition I've designed. Hope everyone is good. Okay, so we can have the next page. Example. Find the equation. Find the equation of the tangent and in normal to a parabola y squared is equal to 12 brackets x plus 3 at a point at a point 0, 6. At a point 0.06. So first of all, we need to get the gradient function of a curve. From y squared is equal to 12 of x plus 3 we can see that 2y of dy dx is equal to 12. So dy dx is equal to 6 out of y. Now, the gradient function as dy dx of the point 0.6, when y is 6, we shall have 6 out of 6, and the gradient m is going to be 1. So that is the gradient of the tangent. So gradient of the tangent is actually what? 1. Then the gradient of the normal, can as well be identified, which is 1 times -1, and the answer will be -1. So therefore, y minus 6 out of x minus 0 is equal to 1. Therefore, y minus 6 is equal to x. So the equation of the tangent is y is equal to x plus 6.
Excuse me, teacher.
Yes, please.
The -1, how did it come about?
Okay. M times -1 times m2 is equal to -1. Eh?
Oh, I understand. Thank
You
you.
understand? Okay. That is why we expect knowledge of O-level primary to be very, very close. When we move up to something, please be steady. Okay, now more action. The normal we have also seen its gradient is -1. So y minus the same point, x minus 0 gives us now this time around a -1. So we shall have y minus 6 is equal to -x. So we shall have y plus x is equal to 6 is the equation of the normal to the parabola. This one is for the tangent. Okay. Screenshot that. We have example 2. Show that proofs can come in these numbers. Show that the point a out of m squared, comma, 2a out of m, close brackets, lies on the parabola y squared is equal to 4ax for any value of m not equal to 0. And then show that the line y is equal to mx plus a over m is a tangent to the parabola y squared is equal to 4ax. Okay. To start with, we have been given y squared is equal to 4ax. We have been given a point a out of m squared, 2a out of m. If I substitute, I let the left-hand side be y squared. You see that y squared will be equal to 4a squared over m squared. Then right-hand side is 4ax, which is going to be equal to 4a times a out of m squared. Hashtag, they are the same. Hence, the point lies on the parabola. So you just need to confirm that.
I beg your pardon.
You just need to confirm that condition, that actually it satisfies. This has given us 4a squared out of m squared. It's that if you get this x value and you put it here, the answer you get on the right-hand side should be the same answer if you were to get a y value and you put it in the position of y. So we have got this answer, we have got that answer, both left and right. Hence, the point satisfies the condition of being an equation of a parabola once substituted in the equation of a parabola.
So I beg your pardon.
Okay, let me use a new page. I am saying that they have told us to show that this point a squared over, was it a squared? That the point a out of m and a squared out of what? Sorry, and 2a out of
m.
This one was out of m squared. That
Yes.
satisfies the, or it lies on the parabola. If it lies on the parabola, they are indirectly telling you to show that that point satisfies that equation. Okay, so you let the left-hand side be y squared, which will give me 2a over m squared, and this gives me 4a what? Squared over m what? Squared. Then the right-hand side, which is 4ax. Substitute the value of x. You'll have 4a times 2a. Sorry. This is an a out of m squared. You realize that this gives you 4a squared over m squared. So since equation 2 is equal to equation 1, hence the point satisfies the equation of the parabola, hence that point lies on the parabola. Since Roman 2 is equal to Roman 1, hence the point lies on the parabola. Then the question 2 is saying, show that the equation of the tangent is that. Now we can get the equation of the tangent from, remember y squared is equal to 4ax. So 2y using parametric equations of differentiation is going to be given by 4a. So dy dx will give us 2a out of y. Now get the gradient at that point. Dy dx at which point? At the point a over m squared and 2a over m. This gradient function will become 2a out of 2a out of m. Vamush, vamush, the gradient becomes m. And this is the gradient of the what? The gradient of the tangent, where at a over m squared 2a over m. So if that is the point where the gradient is, then y minus 2a over m out of x minus a over m squared is equal to m. We shall have ym minus 2a over m divided by, is equal to mx minus a over m. When you simplify, you realize ym minus 2a over m is equal to m squared of x minus a over m. Vamush the m. When the m has been lost, we can have the following. Can have ym minus m squared of x minus a is equal to 0. The question made y the subject, so we shall have y is equal to m squared x plus a divided by m divided by m. Finally, y would be x out of m plus a out of m. Hashtag solution. Sorry, this is a out of m plus what? Plus x times m. So the equation finally becomes xm plus a out of m. Hence proof. That is exactly what the question wanted. Okay. Let's have this other last one on this kind. Find the equation for all tangents drawn to the curve y is equal to x squared minus 8x plus 3 from a point 0, -6. Ukash, are you there? Ukash. Ukash, I can't hear you.
Yes, please, sir.
Read the question.
They are saying that find the equation for all tangents.
Drawn?
Don't to the curve y is equal to x squared minus 8x plus 3 from a point 6 negative 6.
Now, there's a reason why I wanted you to read that question. Is it the same parabola as we have been seeing? Gosh.
No.
What kind of parabola is that? Vertical, horizontal? Is it a vertical parabola or horizontal parabola?
It's a vertical.
Why? These are questions they will ask you in a discussion. Hey, why?
It's because it's because x has a greater power.
Thank you so much. It's because x is squared. Okay. I wanted to confirm that you studied with that. So I think now you see that the curve is different. Okay. So since you're the one who brought that question, that's why I was on your case, so that I can confirm that you can distinguish anytime whenever the curve is changed. So according to that question, we have a vertical parabola.
Excuse me, sir.
Yes, please.
A screenshot of the previous page.
Okay.
I'm
Okay,
done. Thank you.
You're welcome. So that is our parabola. It looks like that. So the point is here. They have said it from a point 0, negative 6. The curve is y is equal to x squared minus 8x plus 3. So the tangent can have an equation of the form y is equal to mx plus c. All right? Now, if you substitute y is equal to mx plus c into the equation of the parabola, then we can have the following. Mx plus c is equal to x squared minus 8x plus 3. So x squared minus 8 plus m of x plus 3 minus c is equal to 0. Remember, if you look at this as a quadratic, this will be capital A, this will be capital B, this will be capital C. Yeah? But for tangent, remember what he said for tangent? Yesterday we discussed that, I think, in ellipse. For tangent, b squared minus 4a capital C should be what? It has only one point of contact. So for a tangent, that is supposed to be equal, not greater. So because if it is greater or equal to, those are two options. So for one option, it has to be what? One option, it has to be equal to. So for that reason, we shall have 8 plus m squared minus 4 times 1 times 3 minus c is equal to 0. So with this, you shall have 8 plus m squared minus 12 plus 4c is equal to 0. So therefore, 8 plus m squared we have seen is equal to 12 minus 4c. Now go back to the other equation. From y is equal to mx plus c. When I substitute there at this point, I will have y is negative 6 is equal to 0 plus c. I can confirm the intercept as negative 6. So if the intercept is negative 6, I'll have 8 plus m squared is equal to 12 plus 24. So 8 plus m to the square is equal to 36. You will confirm 8 plus m is equal to plus or minus 6 my m is 114, my second m is 2. I get 2. When this one moved over, yeah. When this one became, wait, C was what? C was -6, eh? When C is -6, when you substitute it here, you get a positive 24. That's 36, you get what? Yeah, I think that is okay. I think that's fine. So therefore, the tangents are, or the lines that are tangential will be y. From y is equal to mx plus c, you have y is equal to 14 of x minus 6. Y is equal to 2x minus 6. Okay, that those become our equations of the what? Of the line that can be drawn from that point to the parabola. Now, you know why that is possible? Maybe I've just drawn it like that, but perhaps it was like this. It could have been like this, whereby down this way is what? 0, -6. Then the lines can come from here. One may say, but teacher, how is that possible? It looks like we only have one tangent. Can also have another one from this way. Normally, that possibility is there if the point is ahead of the vertex. Are you getting the mathematics I'm trying to illustrate here? Or I'm speaking to myself. I'm saying this is possible if that point is ahead of the vertex. Or it can be, okay, it can also be in this form. I just wanted to show you that it is possible. One may wonder, you drew only one tangent. How come there are 2? I'm trying to show you why they can be 2. Yes, someone has a question.
How did you get 14 and 2?
Hey, wait a minute. Wait a minute. When 8 crosses over, it becomes a negative. So we have -14 and -2. My bad. So this gives us a -14 and -2. Wow. You see how we had crashed at the last minute. I forgot this 8 crossed over. When it crosses over, it becomes a -8. So -8 plus 6, you get a -2. -8 minus 6, you get a -14. Thank you so much, Habiba. Okay, those are not so complicated. Now let us go for the interesting ones. Time is flying so fast. Equation of the tangent to the parabola at a point 80 squared to 80. Now, given that y squared is equal to 4ax, we all know that equation. It's the standard equation for the what? For the parabola. If I have a parabola of this kind, and in my parabola is at a point P, which is 80 squared to 80. And at that point is where we have the tangent, as the question is, as the statement says. Okay. Then this is what is likely to happen. There are 2 methods you can use. One, you can use the other, and we have already seen that 2y of dy dx is equal to 4a. One can say dy dx is equal to 4a over 2y. Substitute 4a over 2 times 2at. Vamos, vamos, vamos. dy dx is 1 over t. Very correct. But another one can say that me, I'm very good at differentiation. If I don't want to use that method, yes, please.
Please, I
Screenshot.
request that you go back.
So as she takes the screenshot, I was saying this one was confirming that the gradient function at that point becomes 1 over t. When it is in terms of parameters, then another person may say, me, I'm very good at differentiation. Why don't I see that y is equal to 80? X is equal to 80 squared. Chain rule, dy dx is dy dt at times dt what? Dx. Hope everyone remembers. I don't want people to start saying, now teacher, how have you got that? How do you differentiate? Hey, ma'am, guys, you must be steady by now. You are close to your name. We are almost like 3 topics away to the final wind up of the syllabus. So I expect everyone to have some of these at their tips. So dy dx becomes 2a. Times dt dx is going to be 1 over 2at. Vamos, vamos. The gradient function becomes 1 out of t, which is the same. So this becomes your m. Now the point, remember, p is 80 squared to 80. How do we get the equation of a line, which is our tangent? When we know the point and we know the gradient, we use any arbitrary point y minus 280 over its corresponding arbitrary coordinate of x minus 80 squared is equal to the gradient, which is 1 over t. This will give me yt minus 280 squared is equal to xt minus 80 squared. This will give me yt a minus xt a minus 80 squared. It is from here that the general equation always can be stated as the following. Wait, is this xt? No, this x has not t. This x has not t. Sorry for this. So if this x has no t, how does it look like? It looks like this. This is x minus 80 squared. So this is x alone. So with that, we can say x minus yt plus 80 squared is equal to 0 is the standard equation of a parabola at a point 80 squared to 80. For the normal, it has a gradient m prime, which m prime is negative 1 over m. So the gradient of the normal will be 1 a negative out of 1 out of t. So the gradient of the normal is actually negative t. So at the same point, you can find the normal, which is y minus 280 out of x minus 80 squared is equal to negative t. Y minus 280 is equal to a negative xt a plus 80 cubed. From today on, whatever we discuss in parabola is examinable. Whether proof or what, they can all be asked. They can ask you to show that the tangent is that one. So, especially in terms of a and t. They'll even come in terms of ap squared to ap, hu squared to hu. So they can alter the t to any other variable. So we can have y plus xt minus 280 minus 80 cubed is 0 is the equation of the normal at this point we have just seen. So if I'm to draw the normal there, it looks like this. Okay, that is the normal. at that point. So this one is the normal at 80 squared to 80. This one is the what? Tangent. Of course, if it's the normal, this is angle is 90. So far, we good with the derivation? They can ask you to show that the equation of the normal to the parabola, blah, 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 is what I've derived. I was going to ask you, but now you will go and do that. You can go to Backhouse 1. Backhouse 1, page 435. Miscellaneous exercise 2G. Question 16, question 17. They set them as curves, but in actual sense, they were talking about a curve, which is a parabola. They were set as curves to find their gradients, their tangents, their normals, blah, 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 the equations of them. But in actual sense, by then, students they knew had not yet covered conic sections. So they were not in position to mention that for a parabola or for a curve. They said for a curve. So they handled it as just any other simple curve. Okay. Today I might just give definitions as I'm seeing here. Okay. Let's go as far as we can so that by the time you go to school, you are happy. So after getting those equations, we have points of intersection. Points of intersection of two tangents to the parabola at points. The first one is P, which is AP squared, comma, 2AP. And the second one is Q, which is A Q squared, 2AQ. That's why I told you they will always vary the T. Now they have brought the T here in terms of what? In terms of P and Q. So don't be confused, be steady. Be like students who are taught by 5-star teachers and be like, yeah, I can understand this is a parabola. Yeah? So they can ask you to prove that the following is true. Is someone having a chat? Let me check. Someone is in the chat. What is this trying to say? Teacher, what has removed from our topic about it? Teacher, what has been removed from our topic about parabola? I heard you talk about it yesterday. What has been removed? They removed, it is the hyperbola. But we have the rectangular hyperbola, so there's one more left. That one, I think you'll find it in short videos. There were 4. Of course, there are 5 plus a circle, but a circle, that one we take it lightly. But these mainly 3, ellipse, parabola, rectangular hyperbola, and hyperbola. The hyperbola was removed, so we are dealing with only the rectangular hyperbola. It was confusing students very much with the ellipse. So they knew that students of these days can't handle. So it says, prove that the tangents, I've told you everything after that can be asked, to the parabola at y, to the parabola, y squared is equal to 4ax at points P of AP squared, 2AP, and Q, AQ squared, 2AQ, meet at a point, which is what? Capital T of brackets, AP2, comma, A into P plus Q, close brackets, close biggest bracket. Very good question. Hope you are ready to see how we handle. We can assume this is our axis. That is our axis. We can have this as our parabola. What has shaped me? That is our parabola. We can assume we are meeting our parabola. The tangents meet from our parabola at some point this way. And then another one comes from this way, and they meet somewhere there. So this is the point capital T. This is the point here P, which is AP squared to AP. Then this is the point here Q, which is AQ squared to AQ. Okay? So we all know, first of all, now sometimes these questions have very many marks, 6 marks you derive from the beginning. Get the value of the gradient, blah, 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 substitute in the equation, action, But if the marks are not so many, we can quote the equations. But for me, let me do everything starting from the beginning. So starting from the beginning, we can get the gradient function of the parabola. So the gradient function of the parabola is got by differentiating, remember, either using parametric equations or differentiating the function of the curve.
Excuse me, sir. Excuse me, sir.
Yes, please.
The previous page. The previous page. Check it.
There you go. Remind me to send you questions on these conic sections, so that you can get to know that the world is not simple. So 2y of dy dx is going to be equal to 4a. So dy dx is equal to 2a out of y. So we can see that at this point, what shall we have? Dy dx, that is when y is equal to ap. This is going to be equal to 1 out of p. You know why. Therefore, y minus 2ap out of x minus 8p squared is equal to 1 out of p. You will have yp minus 2ap squared is equal to x minus ap squared, which will give us x minus py plus ap squared is 0, equation 1. So since I've already done that, consequently, I can reduce the second one. So at hu squared to hu, the tangent is going to be x minus qy plus aq squared is equal to 0. This is equation 2. Now, if these two lines meet, remember we have done coordinate geometry, and we know when lines intersect, we solve them simultaneously. Okay, so I can subtract Roman 1 minus Roman 2. I'll vamoosh the x, and I'll have q minus p of y. Okay, plus a p squared minus a q squared is 0. I'll have q minus p of y is equal to a brackets of q minus p brackets of q plus p. I vamoosh this by division. My y becomes a brackets q plus p, equation star. That is the y at t, at the point of intersection. Then what is the x? I get this y substitute in any. I can, for example, use x minus qy plus aq squared is 0. I'll get x minus q brackets a bracket q plus p close biggest bracket a plus aq squared is 0. This will open up and say this is x minus aq squared a minus aqp a plus aq squared is 0 I vamoosh the 2 by subtraction. Finally, my x becomes a q p. Therefore, our point of intersection of the 2 tangents will become a q p, comma, a brackets q plus p, close brackets, close biggest bracket. You will find other questions coming in this form. A T1, T2, comma, brackets, T1 plus T2. They're asking you for the same ideology. They'll also give it in this case, A P1, P2, comma, A brackets, P1, a plus, P2, close bracket, close biggest bracket. So they're bringing the same idea. It's just that the parameters would be varying at that instant. Yes, please.
Is it possible?
Is it possible?
Is it possible to make x and y the subject?
Where?
Conjugating conjugating the coordinates of t.
To make them the subject. Where? From these 2 equations.
Yes.
And then you substitute using substitution method. It is okay. Okay. Very fast. We have 10 minutes. Equation of the chord to a parabola. Y squared is equal to 4ax. Joining points P brackets AP squared 2AP and the Q, which is AQ squared and 2AQ. I told you all these can be examined, so be very sensitive. So this is another definition. You can bring a parabola of this kind. And they can tell us we have a point here and a point there. And if you have a common chord that cuts through, which can be like this one, and when that chord cuts through, you have this point P, which is AP squared to AP. Then you have this point Q, which is, yes, Nabunya Angel, AQ squared to AQ. Girls, you're so quiet today. What's up? You are enjoying the class, or by you are seeing fireworks? You're enjoying?
Very.
Yeah? Anyway, if you have understood these items from the beginning, these other ones just follow the knowledge of what you have before in coordinate geometry. Now we are saying we want to find the equation of the chord of the parabola. The chord joining may be P to Q. It even P to Q can even be like this, guys. Don't only think about that one. It can even be like this. Hey, where are my straight lines? It can even be like this, whereby this can be your P, this can be your Q. This P prime would have AP prime squared to AP prime. Then this one can have HU prime squared to HU. So that the blue can be a chord, the green can be a chord, as long as the line cuts. Even this one is true. Let me show you one last one here. Even this one can be true. It can be a chord. Okay, so a chord can be anything of those kinds, right? So with that, let's see what this one's made of. Now, to start with, get the gradient of the chord. Gradient of the chord, this color, might not see very well. Gradient of the chord is going to be 2AP minus 2AQ divided by AP squared minus AQ squared. This will give us twice of A brackets P minus Q brackets divided by A brackets P squared minus Q squared. Of course, down you say difference of two squares. The gradient becomes 2 out of P plus Q. So if that is the gradient of the chord, choose any point, any you want, whether P or Q. Use it and use the definition of equations of a line, hence you get the solution. So I can say I want to use P. You know, it is always good to use the obvious ones. P is more obvious. Remember, P is AP squared to AP. The gradient M we have seen is 2 out of P plus Q, okay? Y minus 2AP divided by X minus AP squared will give me twice, or is over, P plus Q.
Excuse me, teacher.
Yes, please. Screenshot.
Please, yes.
I had thought that someone is already steady taking screenshots, sends in the group all the time, so that people can be consistent also. Okay, I think you are done. Eh? Are you done? Or I go back?
Yes, thank you, teacher.
Welcome. Okay, guys, so we can proceed with this algebra. We shall have y p plus y q minus 2AP squared minus 2APQ is equal to 2x minus 2AP squared. The 2AP squared is on both sides. We can vamoosh it by subtraction. Finally, what do we have? We shall have y brackets p plus q close brackets minus 2x minus 2APQ is equal to 0 is the equation of the common chord. Is the equation of the chord. Okay. Which other definition should I give you? Yeah, one last definition, condition of the focal chord. Condition of the focal chord. Mr. Kabagabe yesterday spent some 5 minutes watching our video as he had us say, hey, we pray it doesn't come very fast. Hey, we pray it's not here. He was just there smiling, wondering what is made of us. Okay, let us this time around don't disappoint him so much. Okay. Now, if this is my curve, this is my parabola. Now, remember, we have what we call a focus. I remember I talked about a focal chord. I mean a focus. Now, the focus is where we have the A0, if you remember. Now, in that focus, we are having the following points. We have a point P, which is AP squared to AP. Then we have a point what? Q, which has AQ squared to AQ. Now, this line, the chord is passing through the focus, so we call it a focal chord. Yeah? So a A focal chord is a chord that passes through the focus of the parabola. So it is also true if someone drew these other lines like these ones. What if someone said, mine is like this? You are correct. Mine is like that. You are correct. Mine is this one. You are very fine, as long as it passes through here and meets the parabola. Okay? So it is very, very okay. All right? So don't worry so much. So the focal chord can take such a look or such a shape. So case one, from the equations of the chord above, so from the equation of the chord here, star, okay, we know S is at S0. And the equation of the chord we have seen is 2x plus 2AP2 minus y of p plus 2 is 0. Okay. Now, if you look at this, y is 0. When you put in y is 0, you'll get 2x plus 2APQ minus 0 is equal to 0. You confirm that according to this, what is our x value? Our x value is A. So we shall have 2A plus 2APQ is equal to 0. All right. And in this case, if you factorize, you get 2A into 1 plus P times Q is equal to 0. And thus A is not equal to 0 because the focus is not at the origin. Then, secondly, we can see that if this is not true, then it should be this one that is true. With that, PQ is going to be equal to a -1 is the condition for a focal chord. So if the values of P and the Q, when you multiply together, they give you -1, then it means that you get what we call the focal chord. And actually it comes from their diameters. I mean, their gradients. So that is method 1. For method 2, to prove that, consider gradients. Consider gradients, whereby gradient of PS should be cogradient of 2S, which is going to be 2AP minus 0 out of AP squared minus A. Is going to be equal to 2AQ minus 0 out of AQ squared minus A. When you simplify, you realize the following. The ADA is everywhere. Yeah? You are study students. If I say divide, you know what I mean. If I say divide, you understand. Because now time is up, I can't overwrite down. So we shall have 2P out of P squared minus 1 is equal to Q out of Q squared minus 1. This gives me, I vamush the 2. All right? When I vamush the 2, this is what is going to happen. I'll have PQ squared minus P is equal to P squared Q minus Q. All right? With that sense, what do we have? We shall have the following. We shall have P2 squared minus P squared Q is going to be equal to P minus Q. Then we shall have here PQ, open brackets, Q minus P is equal to P minus Q. When I simplify further by division, this is a negativity of 1, confirming steadiness that PQ is equal to a -1. Hence, we can use this as a condition still to prove that we have a condition for the focal chord. Yes, Mr. Kabagambe, you found where you are summarizing very fast. We are just we are done, but thank you so much. Students, the rest of the definitions, please follow me on TikTok. Actually, I was about to get done with the topic. Follow me on TikTok, follow me on YouTube, and you shall see how I can put there some of those aspects. But I would like to thank you for your generous attendance and for your commitment as learners. Please stay committed in any way or the other. Stay on your WhatsApp groups in case of any communications, and I pray for the best. I trust that if you've all been attentive in all these courses we have handled, I trust that all of you can score A's out of these subjects. May God bless you, help you and guide in all that you do, and stay safe, stay healthy, so that we can meet again in class or even on Zoom once again. May God keep everyone safe. Please take the screenshot, and I close as the teacher is already here.
Thank you, teacher.
Anytime.
Thank you, teacher.
Anytime.
Thank you.
You're welcome.